Hello, dear friends in Choueifat School, grade 9. This is Wael Bashuri, math and physics teacher. In this video, I'm going to solve some questions from week 6 physics. I was asked about these questions, so they are very important. Let's start solving question number 1. The refraction of light is being investigated using rectangular perspex block as shown below. Which of the following observations are true in the investigation? Select all that apply. If you look at the diagram here, you can easily notice that refraction at A, the ray of light bends towards the normal. But here at B, refraction is away from the normal. So the refracted ray is away from the normal because of this angle is greater than this angle. So any option which tells us that the refracted ray is towards the normal, we have to choose it here. Another important thing here you can notice in this diagram is that the emergent ray here is parallel to the incident ray. So incident and emergent are parallel. Now let's see the options. Here you can see at point A, the refracted ray is bent towards the normal. Yes, at point A towards the normal. And also the emergent ray is parallel to the incident ray. This is also correct. Other options are wrong. Now let's see question number 18. Okay, a boy of height L, 1.50 meters, standing at x equal 2 meters from the edge of an empty swimming pool, depth d equals 3, cannot see a coin at the bottom. He can see the coin only when the pool is completely filled with water. Take the index of refraction of water to be 4/3. Find the distance d between the coin and the wall. Okay, so our target is to find point D. Let's write all the given information. The length is 1.5, then x is 2, then we have refractive index, and we have d equals 3. So 1.5, 2, and 3, let's write them on the diagram here. Here you have 1.5, you have 2, here you have 3. First thing we can do here is to find angle alpha. So let's find angle alpha. Here you can say tan alpha is equal to opposite, which is 1.5, over adjacent, which is 2. Now we do shift tan this amount, so we get alpha equal 36.8. So here you have 36.8. Next step, let us find the angle here. This is angle of incidence I, so let's find it. If this is 36.8 or 37, so angle I must be, in this case, 53. So let's write here 53. Now we can use Snell's law to calculate angle theta. So here we can see Snell's law, N1 sine I equal N2 sine R. So N1 is coming from air, so this is 1. Sine I sine 53 equal N2. N2 is refractive index of glass given to us here, of water given to us here, 4/3 times sine R. Now if you do the math calculations here, you can see sine R is equal to sine 53 divided by 4/3. Let's write it here, sine 53.13 to be accurate. So this is 53.13. Now, if you do shift sign to this amount, you get R is equal to 36.87 Now you have to do, so this angle is here. This is angle theta. Now you can use trigonometry again in this right angle triangle to calculate the distance d. So you can do tan 36.87 equal to opposite, which is d, divided by adjacent, which is 3, multiply or cross multiply 3 times tan 36.87. So you get 2.25, and that is the answer. Now we'll do question number 11. Rami is looking at a coin resting at the bottom of 2 meters water pool. The coin appears to be floating in the middle of the pool as shown. Fill in the blank. Knowing that the index of refraction of water is 1.33, the apparent depth of the coin to 1 decimal place is. Now the formula here is very easy. Refractive index is equal to real depth over apparent depth. Real over apparent. Refractive index is 1.33. Now the real depth here, that's what we have to do. Knowing that the index of refraction, the apparent depth of the coin to 1 decimal place, the apparent depth is unknown here, and the real depth is known. So the real depth is given to us in the question. So the real depth is 2, and apparent depth we don't have it. Now we cross multiply. So we get 1.33 multiplied by A is equal to 2. Apparent depth is equal to 2 divided by 1.33, and then use your calculator to find the answer. Now let's do question number 19. Okay, the diagram below shows a ray of light incident on a curved part of a semicircular glass block at point M. Refractive index of block is greater than n. Point N is the center of the flat face of the semicircular block. Choose the correct answer to complete the sentence below. At M, the ray is incident normal to the surface, thus will continue. Here we choose undeviated, because when it comes normal, it continues undeviated. At M, the ray strikes with an angle, thus it will refract away from the normal as it exits the block. If the ray of light strikes the point N at an angle 42, then the emergent ray grazes the surface. Here they are telling us that 42 is critical angle. Because of the word grazes. Grazes the surface means at right angle to the normal, or 90 degrees to the normal. So bear this in mind. The angle 42 is then called critical angle. So here we write critical angle, angle C, or critical angle. The value of refractive index of glass, now here refractive index is equal to sine 90 divided by sine critical angle. So just plug 42 here. So it becomes sine 90 is 1. 1 divided by sine 42. Now question number 22 also is important and has an idea which needs to be explained. A ray of yellow light is incident at a prism shown below. At point O, the ray bends inside prism, then leaves it and hits the screen at point Y. If the ray of red light is incident at the same angle and at the same point as yellow ray, then the red spot on the screen will be what? Okay, here if the red instead of yellow, we know that in dispersion, when white light comes like this, it refracts like this. So here we'll have rho G bev. Roy E. Bev, which means red, orange, yellow, green, blue, indigo, violet. Here you can easily notice that red must be above yellow. So here we have to choose above. If red instead of yellow, it will be above. So here above. The dependent of speed of light in matter on color of light is a phenomenon called dispersion. So here we write dispersion. Now write in comments in case you have any question you want to do, and then I will make a video and solve all the questions you need to do. Thank you very much.